Let's look at the box plot. A box plot is a way to display the data using the 5-number summary and noting any outliers. The 5-number summary is the following. The minimum, Q1 or the first quartile, the median, Q3 or the third quartile, and the maximum. So the 5-number summary is the minimum, Q1, the median, Q3, and the maximum. Here is a box plot. Notice that in the center we have a box. That's where the majority of the data lies. On the left side of the box we have a whisker, and that is where the data value extends all the way to the minimum. And on the right side we also have another whisker, and that's where the data value extends to the maximum. If you look at the regions of the box plot, the minimum is the lowest value. This edge of this box is Q1. The middle of the box here is the median. The right side of the box is Q3. And so the box plot allows us to visualize the amount of spread the data has. The majority of the data is in the box, while there are a few data values that are to the left and to the right of that. We also have the box represents the interquartile range, or IQR. The interquartile range, IQR, is equal to Q3 minus Q1. So to find it, we just need to subtract the third quartile by the first quartile, and that will give us a range for where most of the values are. Remember, quartiles separate the data into quarters. So from the minimum to Q1, that's 25% of the data. From the minimum to the median, that's 50% of the data. And from Q3 to the minimum, that's 75% of the data. You could also think of it in another way. From the minimum to Q1, that's 25% of the data. From Q1 to the median, that's another 25%. And from the median to Q3, that's going to be another 25%. From Q3 to the maximum, that's another 25%. And from that, we can conclude that the interquartile range consists of the big portion, or 50% of the data. Now the question is, why are box plots important? Well, they allow us to see the shape of the distribution. Here I have 3 examples of box plots. Notice that the tail is longer on the left, so this is known as left skewed. This means that most of the data is on the right side, but very few people are on the left side. In the center here we have a data that's pretty symmetric. We have the tail on the left and the tail on the right is pretty much the same distance, so this is a data that's symmetric. In the last example, the tail is longer on the right side, so this is considered right skewed. Now again, remember, if the tail is on the left, it is skewed left. If the tail is on the right, it is skewed right. Let's figure out how to draw a box plot. Step 1, make a uniform scale along the horizontal axis. Step 2, draw vertical lines at Q1, the median, and Q3. And we want to enclose these lines in a box. Step 3, we want to find the values of the lower and upper fences, and we'll calculate those in the next slide. Step 4, extend horizontal lines, or whiskers, from Q1 and Q3 out to the data values just inside the fences. The key word is just inside the fences. So you want to select values that are above the lower fence and just below the upper fence. Step 5. Indicate any outliers with an asterisk. Step 6. Title and label the box plot. Note, outliers are values that are extreme in relationship to the rest of the data values. In order to find outliers, we must first determine the first and third quartiles of the data, then compute the interquartile range, IQR, which is calculated by taking Q3 and subtracting Q1 from it. Then we can determine the fences. The lower fence is equivalent to Q1 minus 1.5 times the interquartile range. The upper fence is equal to Q3 plus 1.5 times the interquartile range. If a data value is less than the lower fence or greater than the upper fence, it's considered an outlier. Example, every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the United States. The following data are the interest rates charged by 10 credit card issuers randomly selected for the July 2005 survey. In this example, I want to determine the 5-number summary of the data, determine if there are any outliers, and we will draw a box plot. The first thing we need to do to find the 5-number summary is to arrange our data values from smallest to biggest, and we will do that first. I have arranged the data values from smallest to biggest. We have 6.5% all the way up to the highest 14.5%. Now remember, the 5-number summary is the minimum, Q1, the median, Q3, and the maximum. I always start by looking for the minimum first. That's going to be 6.5%. The maximum is the 14.5%. After I find the minimum and the maximum, I always look for the median next. Remember, the median is the number in the middle. And since we have 10 data values, that's going to be the 2 numbers in the middle, and we'll have to add them up and divide by 2. The 2 numbers in the middle are 13.3% and 13.9%. We're going to add these up and divide by 2 to find the median. The median is equal to 13.3 plus 13.9 divided by 2. And this gives us a median of 13.6. The median of the first half is 12%. Looking at the upper half, the median is 14.4%. So here is my 5-number summary. We have the minimum is 6.5%, Q1 is 12%, the median is 13.6%, Q3 is 14.4%, and our maximum is 14.5%. Next, we're going to determine if there are any outliers. In order to do that, we'll have to look at the lower fence, and we'll have to look at the upper fence. The lower fence is equal to Q1 minus 1.5 times IQR. The upper fence is equal to Q3 plus 1.5 times IQR. Let's recall the 5-number summary. The minimum, Q1, the median, Q3, and the maximum. And our numbers are 6.5, 12.0, 13.6, 14.4, and 14.5. We'll find the IQR first, the interquartile range. and that's equal to Q3 minus Q1. So we're going to take 14.4 and subtract 12.0. This gives us an IQR of 2.4. Now, since we have found the IQR, we can use that to calculate the lower fence and upper fence. The lower fence is equal to Q1 minus 1.5 times IQR. Q1 is 12, so we'll put 12 minus 1.5 times the IQR, which we already know is equal to 2.4. We can enter this in a calculator, and this gives us 8.4 as the lower fence. The upper fence is equal to Q3 plus 1.5 times IQR. And Q3 is 14.4 plus 1.5 times IQR, which again is 2.4. Using our calculator, we get the upper fence is 18. The lower fence is 8.4, so we'll write it down. And the upper fence is 18, and we'll also write that down. To see if there's outliers, we have to check if anything is outside our property. Is there anything that's less than 8.4 in the data set? I look at my data set, and 6.5 is less than 8.4, so 6.5 is an outlier. 6.5 is an outlier. And then I look at the upper fence. The upper fence is 18. 18 is all the way over here, and everything is inside my property less than 18. There's no outliers above 18, but there is one outlier that's below our lower fence 8.4, so we only have one outlier, 6.5. To draw our box plot, we need the 5-number summary, and recall the 5-number summary. I'm going to draw a line along the horizontal axis, and we'll have our scale. I'm just going to go from 0 to 15 to include all of our data values. Now the first thing we need to draw is Q1, the median, and Q3. Q1 is 12, so I'm going to draw a vertical line at 12. The median is 13.6, so that's going to be between 13 and 14. We'll draw a vertical line between 13 and 14. Q3 is 14.4, so that's going to be between 14 and 15. Remember, this vertical line represents Q1, this vertical line represents the median, and this vertical line represents Q3. We need to enclose these lines in a box, and now we need to draw our whiskers. To do that, we'll have to look at the lower fence. The lower fence is 8.4, and the upper fence is equal to 18. Now I'll need to find our data value that's just above 8.4 inside our property, and that's going to be 9.9%. That's the data value that's just within our fence, 9.9%, and I will graph my whisker up to that point. We have 9.9% as the end point of our lower whisker because that's just inside our fence. Now for the upper fence, we know that the value that's just inside our property below the upper fence is 14.5%. So I'll extend the whisker to around 14.5%. The last thing we need for this graph is the outlier, and recall the outlier was 6.5. So we'll plot 6.5 as an asterisk or a dot, and that's our complete box plot. A quick question for you. What do you think the shape of the distribution looks like? Is it skew right? Is it skew left? Or is this pretty much symmetric? So take a moment to think about that. Is the distribution skew right, skew left, or roughly symmetric? The correct answer is the distribution is skew left. It is skew left because the tail is much longer on the left side, especially with this outlier at 6.5. You are given a box plot and we want to find the 5-number summary. So pause the video and try that on your own. Looking at this box plot, we notice that there are no outliers. There's no asterisk or dot on the left or right side, so there are no outliers. The minimum is the smallest value, and that's going to be 5. Q1 is the left side of the box, and that corresponds to 10. The middle of the box here is the median, and the median is 16. Q3 is the right side of the box, and that corresponds to 19. And the maximum is the highest value, and that is 20. In some situations, we might have a data set that has many values in it, and it will be unreasonable to do the calculations by hand. For this example, I'm going to find the 5-number summary using technology. In real life, statisticians use technology to calculate the 5-number summary. They rarely do the work by hand. So let's do the problem using technology. You will find a link in the homework assignment. To find the 5-number summary, enter the data values in the calculator and select Calculate. The computer gives us the minimum, Q1, the median, Q3, and the maximum. So use this calculator if you want to quickly calculate the 5-number summary.